Welcome back to the GreenMech TV channel. Across Europe, billions of plastic bottles are bought and discarded every year. But what truly happens after you drop them into a recycling bin? The journey begins here, inside a modern PET recycling plant in eastern France, where used bottles are reborn. Most drink bottles are made of PET, a plastic known for its strength, clarity, and most importantly, its ability to be recycled again and again. Each year, this single facility processes billions of bottles, transforming waste into valuable raw material ready to re-enter the production cycle. Once collected from sorting centers, the bottles arrive tightly compressed into large bales. These bales are cut open and fed onto conveyor belts, where the recycling process begins. First, magnetic separators remove any trace of metal, followed by a pre-wash that strips away labels, glue, and impurities. Then comes optical and manual sorting, a critical step to ensure that only clean PET continues forward. Next, the bottles are ground into small flakes. These flakes are carefully analyzed by color and material sensors, which remove anything that isn't pure PET. The clean flakes are dried, melted, and filtered into long, spaghetti-like strands, then cut into tiny uniform pellets. These pellets form the foundation of new plastic products, from fresh bottles to packaging and textiles. In the final stage, the pellets pass through a special decontamination process under nitrogen. This makes them food-grade safe, ready to be used again for drink containers and other applications. Each day, around 4 million bottles complete this remarkable transformation here. What begins as discarded waste ends as a material ready for new life. Every bottle recycled means fewer ending up in landfills, fewer resources wasted, and a cleaner planet for all. PET plastic is made to be remade, closing the loop for a more sustainable future. At the Conyers Material Recovery Facility, the life of paper begins again. Here, massive trucks arrive one after another, filled with recyclable materials gathered from homes and businesses. Each vehicle is weighed, unloaded, and emptied onto the sorting floor, the starting point of a transformation from waste to resource. A front loader moves the mixed recyclables into the in-feed bunker, where a drum feeder evenly distributes them onto the first conveyor. As the material rises, a fine mist controls dust, while workers at the pre-sort line remove large contaminants, anything that doesn't belong in the recycling stream. From there, the material flows onto disc screens that separate cardboard from lighter waste. The cardboard travels upward for inspection and then moves to baling, where it's compressed into large, heavy blocks ready for shipment. Meanwhile, smaller materials fall through to the trommel, a massive rotating cylinder that sorts items by size. Inside the trommel, 3 distinct streams emerge: fines, medium materials, and large items. The fines pass under magnets and eddy currents to extract metals like steel and aluminum. The large materials move to a blower system that separates light plastics from heavier items. Each stream is then refined further by optical sensors and human inspectors who remove any remaining impurities. The medium fraction, a mix of paper, plastic, and cartons, enters the ballistic sorter. This machine divides two-dimensional materials, like paper, from three-dimensional items like bottles or containers. The clean paper stream moves to its final optical sorter, ensuring that what remains is pure mixed paper, free of contamination. Once separated, each recovered material, paper, plastic, aluminum, is conveyed into dedicated bunkers. From there, it's fed onto baling conveyors, compressed into dense, transport-ready cubes, and stacked for delivery to reprocessing plants. Through this carefully engineered system of sorting, separation, and reuse, Pratt Industries turns discarded material into a valuable resource, proving that with technology, teamwork, and commitment to sustainability, waste truly becomes opportunity. Every sheet of recycled paper is a small step toward a cleaner, more circular future. But for mixed paper, the journey continues. These bales are sent directly to the nearby Pratt paper mill, where they're repulped and turned into 100% recycled paper. The huge rolls produced here are then converted into new cardboard boxes and packaging, closing the recycling loop and giving old paper a new life. Every day, millions of packages reach their final stop, the landfill. But what if that end became a new beginning? What if the waste we throw away could return as something new? This is the story of one of the most familiar packages in the world, the humble pizza box. At Walmart stores, used cardboard from daily operations is collected, baled, and sent directly to Pratt Industries, the very supplier that produces Walmart's deli pizza boxes. It's a perfect loop. Old boxes transformed into new ones, closing the cycle of waste within the same supply chain. Inside the Pratt paper mill, the bales of cardboard are broken down and mixed with water, turning into pulp. The pulp is cleaned, pressed, and rolled into strong brown linerboard, 100% recycled material tested for quality and purity. From there, the giant rolls travel to the box plant, where they're fed into corrugating machines. The layers are pressed, fluted, and cut into the sturdy boxes we all recognize. This closed-loop system diverts more than 8,000 tons of waste from landfills every year, saving around 125,000 trees and over 40 million gallons of water. Even the mill itself runs on energy generated from recycled waste and wood byproducts, reducing electricity use by nearly 40%. When the finished boxes reach stores, they once again protect fresh pizzas ready for customers. And when those boxes are recycled, the cycle starts all over again, transforming waste into opportunity, one pizza box at a time. Welcome to the next generation of recycling, where innovation transforms what was once waste into valuable resources. This advanced Tetra Pak recycling line is designed to separate paper, plastic, and aluminum from composite packaging, like beverage cartons, paper cups, and other multi-layer materials, a key step toward a circular economy. The process begins as cartons are loaded onto a high-efficiency conveyor and enter the paper-plastic separator. Inside, a patented water mixing and friction method breaks the material apart. As the slurry moves forward, paper fibers dissolve into pulp, while plastic films and thin layers of aluminum are separated and collected. Roughly 75% of the output is paper pulp, ready for reuse. Next, the pulp flows into a purification system known as the slag pulp separator. Here, fine plastic threads and impurities are removed, producing a clean, high-quality pulp that can re-enter paper manufacturing. The technology prevents clogging and reduces maintenance downtime, ensuring a smooth and efficient process. The purified pulp then travels to a rotary drum dehydrator, where gravity and rotation remove excess water. Inside the drum, nylon mesh screens help the pulp dry evenly, preparing it for the final recovery stage. Finally, the paper pulp passes through a powerful filter press that compresses it into solid, reusable sheets. At the same time, clean water is filtered and recycled back into the system, minimizing waste and saving resources. By effectively separating paper, plastic, and aluminum, this system turns what used to be a complex waste stream into valuable, reusable materials. It's technology built not only for performance but for purpose, helping industries reduce environmental impact and move closer to a truly circular economy where nothing goes to waste. At the end of their service life, silicon solar panels enter a new stage, one where innovation meets sustainability. Inside this advanced photovoltaic recycling plant, every component is recovered, ensuring that nothing goes to waste. The process begins with infrared monitoring, scanning each panel to detect structure, material type, and damage before dismantling. Next comes the junction box removal system, which automatically detaches electrical boxes and cables for safe separation. The panels then move to the aluminum frame removal system, where precise mechanical arms extract the sturdy metal borders. These frames are fully recyclable and ready to re-enter industrial use. After that, the glass removal system carefully detaches the surface layer without shattering, allowing recovery of clean, reusable glass. Through the glass collection and screening stage, impurities and fine particles are filtered out, leaving high-quality fragments for processing. What remains is the internal layer, EVA sheets and solar cells. The EVA sheet shredder cuts through the bonding material, preparing it for further refinement. Next, the grinding system pulverizes the remaining silicon and metallic components into fine granules. These materials then pass through a copper separating system, where precision sorting extracts valuable metals for reuse. Finally, the electrostatic separator completes the process, isolating pure silicon, copper, and aluminum, materials once locked inside, now ready for a second life. This zero-waste recycling line represents a new frontier in renewable technology, turning expired solar panels into raw materials for the next generation of clean energy. It's not just recycling, it's the rebirth of sunlight itself. As the world shifts toward renewable energy, end-of-life solar panels are creating a new kind of opportunity, one that transforms waste into value. According to the International Renewable Energy Agency, by 2030, the recoverable raw materials from retired panels could be worth over $450 million, enough to produce around 60 million new solar modules. Recycling solar panels not only conserves valuable resources but also prevents tons of waste from ending up in landfills. Most panels today are made using crystalline silicon, a structure composed of glass, aluminum, plastic, copper, and EVA sheets. Together, these components hold incredible potential for reuse. In this advanced recycling system, the process begins with junction box separation, where electrical boxes and wiring are detached for recovery. Next, the aluminum frame separator removes the sturdy metal borders that can be melted and reused indefinitely. The panel then enters the glass separation system, which gently detaches the front layer of glass, representing nearly 75% of the panel's total weight. This glass is cleaned and sent for remanufacturing, rejoining the cycle as a high-quality raw material. Following that, the EVA sheet crushing and recycling stage breaks down the encapsulation layers that once held the solar cells in place. From here, silicon cells and metallic traces are processed and separated for further use in new photovoltaic products. With up to 95% material recovery efficiency, this system operates continuously and can handle 1.5 tons of solar panels every hour. It's a remarkable blend of automation, precision, and environmental responsibility. By rethinking how we treat the waste of yesterday, we're building the clean energy future of tomorrow, where even the sun's oldest technology finds new life again. Compact, efficient, and precise, the Polystar MB Mini-type blown film machine is built to deliver professional quality film production in a small footprint. The process begins as plastic pellets, such as HDPE or LDPE, are fed into the extruder. Inside, they're melted and pushed through a circular die, forming a continuous molten tube. Air is then blown into the center, inflating the film like a balloon. As the bubble rises, it stretches and cools, transforming into a thin, even layer of plastic. Guided rollers collapse the bubble into flat sheets before it's wound into rolls for use in packaging, shopping bags, or industrial liners. Despite its size, this compact machine offers full-scale performance, delivering smooth operation, consistent film thickness, and easy control of speed and air pressure. Designed for flexibility, the MB model supports multiple materials, color master batches, and recycled blends. It can produce film widths from a few centimeters up to several hundred, all while maintaining excellent clarity and strength. The machine's simple design makes setup and maintenance fast, allowing operators to adjust production quickly for different orders. Its energy-efficient motors and steady output make it ideal for small and mid-sized manufacturers aiming for reliable, cost-effective film extrusion. The Polystar MB proves that advanced engineering doesn't have to be large-scale. It's compact innovation in motion, transforming plastic granules into high-quality film with speed, precision, and efficiency. For more than 3 decades, Polystar has been a global leader in extrusion and plastic recycling systems. The company's 2-stage recycling machine is designed to transform printed and post-industrial plastic waste, such as HDPE, LDPE, PP, PS, and PA, back into high-quality reusable pellets. Equipped with advanced automation and pressure control, the HNTVS series automatically adjusts feeding, extrusion, and pellet cutting speeds for maximum performance and safety. Built with powerful mechanics and a compact design, the dual-stage system ensures stable operation, high output, and consistent granule quality, reaching capacities from 80 to over 1,000 kilograms per hour.